Hello, I'm Ramon Canal. I am professor at UPC. Before I get into the talk, I would like to thank the organizers for the invitation. Today, I will be talking about a project, Vitamin 5, that we just started. Basically, the fundamental contribution of the project is that we want to push and basically complete the hardware software stack for IoT and cloud on RISC-V. So the project itself basically is a Horizon project started on January 1st. So from that we have 3 years, and basically that brings us to December 31st on 2025. The project itself, it's called Virtual Environment and Toolboxing for Trustworthy Development of RISC-V based cloud services. And it's a collaboration of 10 partners. Ourselves, UPC, which acts as a coordinator. And then we have Politecnico di Torino and Fondazione Links, also from Torino, the National and Capodistran University of Athens, the Barcelona Supercomputing Center, Virtual Open Systems in France, Zero Point in Sweden, Semi Dynamics in Barcelona, ICCS in Athens, and Exapsys in Thessaloniki in Greece. So these partners basically, together we are trying to develop further the RISC-V open source virtual environments. And basically, as we'll see in a moment, that means a set of simulators and emulators. We also will provide software validation suites in terms of security, malicious code, but also software bugs. And finally, foremost, the cloud hardware and software stack. If we go by one, the first objective is to develop a complete virtual execution environment to favor and support software development. In this case, we will focus on three already available environments. That's QEMU, Gen5, and then we will also be providing a cloud FPGA prototype. Those environments already have partial support to RISC-V at different levels. Basically, with the project, we want to complete that. In terms of the cloud FPGA, basically, what we want is to provide the community with an encrypted FPGA with a RISC-V core that can run on cloud servers, which basically provide the functionality of FPGA. In that sense, we will be able not only to demonstrate the advancements of this project, but we will also be able to run hundreds of nodes at the same time. Altogether, and actually, if we sum up the contributions that we will add to all these frameworks, are the ISA extensions, obviously virtualization, support, cryptography, and bit manipulation and vectorization. Obviously, virtualization is in dire need, obviously, in any cloud or IoT environment. But on top of that, we also need cryptography and bit manipulation and vectorization, especially for the software suites. We will extend the memory and communication interfaces, and we will include extensive hardware monitoring. And that's not only for performance monitoring, but also for security and software test. Finally, we want to provide multi-node simulation, emulation, and execution, as I mentioned before. On the second objective we have, basically, on the software side, we want to develop a tool set, basically, to allow developers to develop validation, verification, and testing the software, fundamentally for the trustworthiness of the software itself. So on one side, we will need some support for that, and basically we will use LLVM for that, and we will extend LLVM and the toolchain to support the ISA extensions I just explained before. But on the research side, we want to provide novel AI approaches for the validation, verification, and test of the software. In this case, we focus mainly on two areas: software bugs like memory leaks, but also malicious code. And we we'll do that fundamentally at runtime and offline. So by analyzing the source code itself, we want to be able to detect that, and also at runtime, and that's why we foresee that we will need a lot of hardware monitoring so that we know exactly what is going on inside the core. The third objective is to develop a complete RISC-V open source stack for cloud services, and we want to target or achieve the same performance as the Dominant X86 setup for the three cloud setups I'll mention in a moment. Just a puntualization here, when I mention ISO performance, obviously we don't have a server with a RISC-V core, obviously with the same core and the same capabilities. So with that, for that, basically we will use the emulated platforms effectively when running the system on top of this virtual machine or on top of this emulator. Fundamentally, we should be achieving the same performance. In terms of the cloud setups, we distributed that and the applications on top of that into three different environments. The first one is what we call a classical approach, and that's an entire virtualized system together with obviously the virtual machines and managed by OpenStack. The second system is the modern approach, and with that we mean that we will use lightweight virtualization through containers, and we will use Kubernetes to manage that. Finally, the serverless approach, we will use function as a service workloads managed by Kata containers and Kubernetes on top of Rust virtual machine. This will be the system setups. Obviously, we will need some software basically to run all these different levels. So we will provide these fundamental software ports and adaptations to build the open source cloud stack. So in terms of virtual machines and container suites, we will target the BOSH monitor, KVM, QEMU, Docker, and Rust VMM and Kata containers, basically to fulfill all the different cloud setups. In terms of cloud management middleware, as we've seen in just a moment ago, we will use OpenStack and Kubernetes, and that's a fundamental software. But obviously, this software has a lot of dependencies, software dependencies and library dependencies. For instance, the Java virtual machine or Python. So we will make sure that all these different software suites are also ported. Finally, in terms of applications, we will demonstrate both AI and big data applications. For instance, Apache Spark and the Google TensorFlow. Following up on the applications, AI and big data obviously are of a big concern, obviously in cloud environments, but also as the emergence of the serverless cloud setups is booming, we will also evaluate serverless application. So for AI, basically we'll use BGG, ResNet, and probably some other networks, state-of-the-art networks, basically used in the industry or in science and research. For big data, we will use TPC benchmarking suites like TPC CDS. And for serverless and fast architectures, basically we'll use function bench and serverless bench. With this presentation, I try to convey you what the project is about and basically what are the software suites and what are we targeting in the next 3 years. So please reach us and get in touch with us if you are interested in the project outcomes. Also, if you are working already on any of these tools, please send us a message so we can collaborate and contribute to the development of this RISC-V ecosystem. Thank you very much for your attention.